Alright, welcome back to another video, and we're back at the 102 with the Discovery Education 7.2. So this was made by US History, so I am going to read this one, Chapter 7, Section 2, live during the Great Depression. So I told you this on my last video, the end of the video actually, so let's get started with the questions.
Herbert Hoover responds to the Great Depression. Page 1.
Depression.
What did President Hoover believe would pull the United States out of the Depression? It was his hunger to believe in Reconstruction Day and relief. What were two fundamental problems with the U.S. economy? 1. Regulations. 2. Temporary inventions. What did Hoover support and use his persuasive abilities to promote? Hoover supported his savings for health and preparing assistance. How did Hoover get Americans back to work? What types of jobs did he create? Meeting business creators and working at the business to create the work to get more rent. A more hands-on approach. Page 2. What was the Federal Home Loan Bank Board? It was the enterprise of gaining more banks and money. What did NCC stand for and what did it do? New construction company and it did not work. It just that the banks didn't get smaller. What did RFC stand for and what did it do? Reconstruction Finance Corporation and it works on the theory of directing the government to improve fine. Amorai Society. Changes. Page 4. By 1933, what percentage of the workforce was unemployed? About 25%. What was a bank failure? It is a federal or state loss when losing the money you have. What happened to a person's money if a bank failed? Banks may fill the money back up. What was a hobo? It is like a homeless vagrant and forced to get in time for the job.
Do you have to stop all the time currently?
What were Hoovervilles? It was a town that was built a long time ago. Name, the Dust Bowl. Page 5. What became a symbol of hard times during the Great Depression? It was a vast amount of growing wheat and species exposed. What did the Great Plains experience during the 1920s? Think rain. It was like leaving the fields go by and seeing them getting taken care of or bothering objects. What destroyed farms, crops, livestock, equipment, and made people ill on the Great Plains? The wind and the water made it what was happening to catch the storms. What did farmers do when they could no longer farm? They decided to leave the Great Plains and to find work at California. How did the Dust Bowl make conditions worse for American farmers? The dust storms were harder for them and made the low prices make it again to improve. Hard time as for Mexican and African Americans. Page 6.
Why did she say it like that?
Racial violence in the South early on during the Great Depression? Dropping the cotton and the sense of littering way back you noticed. Where did African Americans go when they couldn't make money from farming? And why? They worked on trains because they can't stand the dust that was on the way back. What types of jobs did African Americans get in the North? They cooked for sanitation workers to help around the job. How did the Great Depression and the Dust Bowl affect Mexican Americans? They probably faced shifts to each other so that way they are giving opportunities about the processes. Why did Americans push for strict limits on immigration during this time? They were affected by other people that were using the same level.
Okay, so the woman was saying something weird because the words are like sticking a little bit together. I think it's because maybe it's because I didn't put the whole. Maybe it's because I didn't screen it too well. I think it's because the last time I did it was May 11th, so I gotta look around in May 12th. I already did huddling, so I'm gonna do exploration questions of galactic bases. In a new Google Doc, answer the following questions, do research, write brief statements, and copy-paste diagrams and picture-to-answer questions. So I'm going to do one. What is a galaxy? It is a bound of gas that has been in discoveries.
2. In what galaxy is the solar system located? In what part of that galaxy? The Milky Way galaxy. 3. What is the galactic disk? What is the galactic bulge? What is the galactic halo? What is a galactic spiral arm? Why is galactic capitalized in each of those questions? The gas of center sides. The packs of stars. The sphere of volume. They are producing together. They produce together to make connections. 4. Why is hard to map the galaxy from where we are? It's 2/3 out of the way. 5. How many stars are there in our galaxy? 400 billion stars. 6. What shape does our galaxy have? What is the diameter of our galaxy? How far from the center are we located? How long does it take for the solar system to complete one orbit of the galaxy?
It's kind of a lot.
Spiral. 105.700. About 26,000 years. About 225 million years. 7. How old is our galaxy believed to be? 13.51 billion years. 8. How did the galaxy form? When vasts collapsed separately. 9. What is believed to be at the center of the galaxy? What is the evidence for that? It's supermassive. It was a short decision. 10. What is dark matter? It is a technician for particles. 11. What are the major types of galaxies? Elliptical, spiral, and irregular galaxies. 12. What is the Hubble classification scheme? What is the Hubble sequence? Spiral. Scheme identification. 13. What is Hubble's law? What is Hubble's constant? V equals H0d, H0.
All right, um, so I was looking at something that one of my old assignments, which is are not made by me. So I will try to read that. So I am going to click on this, the Inside Out viewing guide that it looks like, but I'll be doing it. I'll be doing it more. Um, okay, so I am not going to be doing all of it because you guys can read some of it if you want to. I apologize if it's. I apologize if my handwriting's kind of bad. I did not finish the rest of it, but I did finish them today. No, this was today. I actually finished them yesterday, so yeah, it says I got all of them done today. So don't worry about that if it was today or if it was yesterday. But it was obviously yesterday at 12:33 p.m. So I'll be reading them in another day. I am going to check on Google Slides. Um, I am going to be doing the Great Society by this project that we did. Did Mr. Kuhn even read it yet? Oh no, he didn't. The Great Society by Quinn Simpson. I did not have a partner. That's okay. What was a Great Society? It was a full definition of series about the responses for Americans that have needed to have conclusions of new major, spending a lot of times with comfort and welcoming this for society. Who called it this and what and when? It was a set of domestic programs or conclusions for producing programs that need activities for this world that needs like currently and patently have each other helping the town in place. Why didn't people like the Great Society? It was a society failure for some people because they didn't know what to do back in the day and they were confused about Watchmen of which to clean and which are kind of confusing for most people as well. What is the lasting legacy of the Great Society? Some people didn't really think hard on that day, or maybe they were misfortune of what they did. In the Great Society of legacy for making or starting from mistakes, pulling for their heads and does that process anyway, but it happens around his action. When did they reform? They had programs of his speech, presidents saying are confident examples of domestic agenda of following citations in which the people are unique of a president that has been noticing a true madness of a session. What was a full definition that has currently happened? It was a complete. It was a like a complete serve for initiatives. Like it was a complete serve for all initiatives for legislation. During the speech was take place for when the president said the university was in a good condition for like common understanding for usual completion for presidents. Excuse me. Currently responsible for President Lyndon B. Came out to speech about domestic agenda for equal purpose, in which meaning could be arrangement for presidents to depend on about which conversation is headed to. Was a full target for that. It was a total limitation for master presidents that can be telling us which human problems can be usually be solved here, or why could it basically happen to this society of this period when people have their feedback. How did the Great Society protect the consumers? They are trying to serve them with Clean Air Act for responses for completion, for speech about consumers' responses. They could like fully use sign a laws until consumers and say, hey, there's no excuse for people paper mills here. This is still manageable for parks as well. What was its quality? It was this like full extension of substitutional rights for equality of rural property or poverty. A match extended in this period during that time was that providing action for Americans to lead to their subsequently during this presidential election. Sources are you can click one of those, you can click on this, and you can also click on that too. That's about it for the Great Society. I have like three assignments that are. I have like four assignments that are not done yet, but I'll be able to get them done around next week. Probably around Monday or so. Probably around. Yeah, yeah, next week. Yeah, next week. Okay, I'll be doing this around next week. Uh, so I forgot to tell you that I'm getting my Chromebook turned in at May 20th. So I'll probably be doing them around Wednesday. I'll probably be doing those videos every day just to get more space in reality times because our Chromebooks are already over because we're not going to be having Chromebooks much longer. What else can we do at this point? What else can I say? All you can do all you can do is just get on your phone. That's about it. We don't have anything else, so yeah. Let's close it out of that. We don't need this. Excuse me. Yeah, I'm still trying to control my asthma. All right, let's talk about the article formation. This is my 2B, which is my 4 period class. Um, I don't know if we're gonna be doing the same as last year because we did so many. We've been to a lot of craziness this year. Well, not this year, but last year. Well, the beginning of the year, we started. We started doing something differently. Okay, so life is gonna be different because I'll be turning 18 in 2 more days. So yeah, tomorrow I'll be going out to eat at Greenwood, and I'll be going to eat there to celebrate my early birthday. Cause I obviously cannot wait to become a young adult uh, so I can be able to manage myself to uh, contain my videos more better, so I can act mature. I'm gonna be so I'm gonna be so I'm gonna do like videos completely. So I'm gonna do like videos competitively different than in the past. I'll be editing videos more often as I can think so. I'll be uploading a video tomorrow, but the edit version will be up at my computer. So I'll be able to do that for those steps. So So yeah, if you guys have any questions, let me know. I'll be able to help you. So let's just get started with this reading. I know it's a lot. Let's get started anyway.
The study of galaxy formation and evolution is concerned with the processes that formed a heterogeneous universe from a homogeneous beginning, the formation of the first galaxies, the way galaxies change over time, and the processes that have generated the variety of structures observed in nearby galaxies. Galaxy formation is hypothesized to occur, from structure formation theories, as a result of tiny quantum fluctuations in the aftermath of the Big Bang. The simplest model for this that is in general agreement with observed phenomena is the Greek letter lambda cold dark matter cosmology, that is to say that clustering and merging is how galaxies gain in mass, and can also determine their shape and structure. The process in which galaxies form and evolve is characterized by steady growth over time, which began shortly after the Big Bang. This process, and the eventual fate of galaxies, remain the subject of intense fascination, and is still fraught with its share of mysteries. Individual galaxies generally evolve through one of three ways. 1. Passive evolution, in which the galaxy remains undisturbed by mergers or interactions, and is devoid of ongoing star formation. These galaxies become steadily fainter and redder as the brighter, high-mass, bluer stars exit the main sequence and evolve into red giants. Otherwise, the galaxy remains unchanged. Isolated, early type, elliptical and S0, galaxies generally evolve in this way. 2. Interactions and mergers which may or may not produce new stars. Interactions in which no new stars are formed result only in the evolution of the morphology of the galaxies. For example, a spiral galaxy may evolve into a S0 galaxy, or an S0 galaxy into an elliptical galaxy, without changing the colors and luminosities of the individual galaxies. On the other hand, interactions that do result in the formation of new stars change the luminosity and color as well as the morphology of each of the galaxies. Bursts of star formation increase the luminosities of the galaxies which, on average, become bluer in color due to the presence of high-mass stars in the young population. However, as the galaxies continue to evolve, their color and luminosity will return to pre-interaction levels as these young, high-mass stars move off the main sequence. 3. In this case, spiral galaxies evolve in color, luminosity and perhaps morphology through the action of internal processes such as the formation of spiral arms or bars. Research into how the population of galaxies as a whole has evolved has provided some important insights into galaxy evolution. One of the most important results, the Butcher-Ohmler effect, shows that on average, galaxies were bluer in the past than they are today. This indicates that the rate of star formation in the universe has declined in recent times, and that the rate of galaxy evolution is slower today than in the past. These observations must now be reproduced by any successful model of galaxy formation and evolution. The earliest stage in the evolution of galaxies is the formation. Galaxies are thought to have begun from large irregular clouds of hydrogen and helium. This gas was created in the first few minutes of the universe. Certain sections of the clouds were probably slightly denser than others. Because of this higher density, gravity caused them to collapse. As the large cloud collapsed, it cooled. On an even smaller scale, pieces of the collapsing cloud also collapsed into even smaller pieces. These smaller, denser regions created the first stars. When the first stars reached the end of their life cycle, they exploded, heating the surrounding gas and slowing the collapse of the galaxy cloud. These explosions also introduced heavier metals, such as carbon and nitrogen, into the galactic cloud. Eventually, this process of collapse, star formation, and slowing, balanced, giving us stable galaxies. When a galaxy forms, it has a disk shape and is called a spiral galaxy due to spiral-like arm structures located on the disk. There are different theories on how these disk-like distributions of stars develop from a cloud of matter. However, at present, none of them exactly predicts the results of observation. The first theory is that as the cloud collapsed to form a galaxy, its spin is what determined what type of galaxy it became. Some theorists believe that spiral galaxies were formed from clouds that had a significant spin. As the cloud collapsed, the spin got even faster still. This is a feature of the principle of angular momentum. As the spin increased, it flattened the material in the cloud along the spin axis, forming the characteristic disk of spiral galaxies. Elliptical galaxies were simply formed from clouds that didn't have this spin. They therefore formed a more round structure, which has no particular axis of rotation. Olin Egan, Donald Lyndon Bell, and Alan Sandage in 1962 proposed a theory that disk galaxies form through a monolithic collapse of a large gas cloud. The distribution of matter in the early universe was in clumps that consisted mostly of dark matter. These clumps interacted gravitationally, putting tidal torques on each other that acted to give them some angular momentum. As the baryonic matter cooled, it dissipated some energy and contracted toward the center. With angular momentum conserved, the matter near the center speeds up its rotation. Then, like a spinning ball of pizza dough, the matter forms into a tight disk. Once the disk cools, the gas is not gravitationally stable, so it cannot remain a singular homogeneous cloud. It breaks, and these smaller clouds of gas form stars. Since the dark matter does not dissipate as it only interacts gravitationally, it remains distributed outside the disk in what is known as the dark halo. Observations show that there are stars located outside the disk, which does not quite fit the pizza dough model. It was first proposed by Leonard Searle and Robert Zinn, 3, that galaxies form by the coalescence of smaller progenitors. Known as a top-down formation scenario, this theory is quite simple yet no longer widely accepted. More recent theories include the clustering of dark matter halos in the bottom-up process. Instead of large gas clouds collapsing to form a galaxy in which the gas breaks up into smaller clouds, it is proposed that matter started out in these smaller clumps, mass on the order of globular clusters, and then many of these clumps merged to form galaxies, 4, which then were drawn by gravitation to form galaxy clusters. This still results in disk-like distributions of baryonic matter with dark matter forming the halo for all the same reasons as in the top-down theory. Models using this sort of process predict more small galaxies than large ones, which matches observations. Astronomers do not currently know what process stops the contraction. In fact, theories of disk galaxy formation are not successful at producing the rotation speed and size of disk galaxies. It has been suggested that the radiation from bright newly formed stars, or from an active galactic nuclei, can slow the contraction of a forming disk. It has also been suggested that the dark matter halo can pull the galaxy, thus stopping disk contraction. Elliptical galaxies have two main stages of evolution. The first is due to the supermassive black hole increasing in size from accreting cooling gas. The second stage is marked by the black hole stabilizing by suppressing gas cooling, thus leaving the elliptical galaxy in a stable state. State 8. The mass of the black hole is also correlated to a property called sigma, which is the dispersion of the velocities of stars in the elliptical galaxies. This relationship, known as the M-sigma relation, was discovered in 2000. Elliptical galaxies do not have disks around them. Although some bulges of disk galaxies look similar to elliptical galaxies, it is more likely to find elliptical galaxies in more crowded regions of the universe, such as galaxy clusters. It is currently believed that elliptical galaxies were formed from collisions of spiral galaxies. This theory is supported by a couple of interesting facts. First, in the early universe, galaxies were much closer together than they are now. Since they were closer together, especially in galaxy clusters, collisions were probably very common. So if collisions of spirals made ellipticals, the process of elliptical galaxy creation was definitely present. Second, large elliptical galaxies typically occur in rich galaxy clusters, where collisions most likely happen. Third, ellipticals don't have much interstellar gas when compared to spirals. Why? In the context of this theory, the collision of spirals would have ignited much of the gas, turning them into stars. This process can be seen today in galaxy collisions. Elliptical galaxies do show evidence of this new population of star formation, even though they currently have very low formation rates. Newer stars have a different metal composition than older stars, since they were created later in the galaxy's evolution, that is, after several star life cycles. Astronomers can measure the amount of heavy metals in a star through a process called spectrophotometry. In some elliptical galaxies, there are two distinct populations of globular clusters, an old and a new. Astronomers now see elliptical galaxies as some of the most evolved systems in the universe. It is widely accepted that the main driving force for the evolution of elliptical galaxies is mergers of smaller galaxies. Many galaxies in the universe are gravitationally bound to other galaxies, which mean that they will never escape the pull of the other galaxy. If the galaxies are of similar size, the resultant galaxy will appear similar to neither of the two galaxies merging, but will instead be an elliptical galaxy.
I am going to stop right here. I'll be reading the rest of it if you don't mind. The merging between such large galaxies is regarded as violent, but because of the vast distances between the stars, that these are like essentially no stellar collisions involved in a collision between two galaxies. However, the frictional interaction of the gas between the two galaxies can use gravitational shock waves, which are capable for forming new stars as the elliptical galaxy forms. By sequencing several images of different galactic collisions, one can observe the timeline of two spiral galaxies merging into a single elliptical galaxy. You can click on those links. You can look at Wikipedia. This can tell you about that. I'm going to be reading the questions. What are the four processes with which galactic evolution and formation are concerned? Extern galaxy, Big Bang pieces, structure, process, returning galaxies. What are the three ways that individual galaxies evolve? Describe each in detail, smallest and intellectual pieces, dimmer ones, and one long ones of structure. What is the Butcher-Oemler effect? The hypothesis zones. From what were galaxies thought to the original form, to like where they are like originally formed. They form when vast clouds prepare to form. How did stellar death affect the rate of star formation in early galaxies? They affect much stars. How did stellar death affect the chemical composition of early galaxies? They form together. What one factor may have been depending of deciding element as to whether or not galaxy was spiral or elliptical? Depends when the Milky Way is not accepted or expected. Briefly explain how a spiral galaxy forms. The full rotation increases. Briefly explain how an elliptical galaxy forms. They use the full shape. How does a galactic collision affect star formation rates? Probably more structure of gases. So that's all I have to read for now. So if you guys have questions, let me know. Like I said, um, if you guys want to wish me a early happy birthday, go ahead. I won't get mad at you for that. I know it's an early birthday. My birthday's only coming for 2 days, so it's not a big deal. You guys can say happy early birthday, Quinn, or whatever. You guys can call me Quinn or Quentin or Quentin. I don't care about that. Or you can call me Mr. Simpson. I don't care. So have a good night, and I'll see you guys in part 103.